Hey students, this is lesson 812. We're going to learn how to use tables to help find solutions, and especially how to use your graphing calculator table feature. And I think this is a good problem for me to use as an example. This is on page 8 in your packet. It's actually on the 8-1 skills practice. But let's start with this. It says, Juanita is crocheting an afghan with an area A close to 24 square feet. The length is 1 foot more than the width W. So just thinking about that, we need to write an equation for that. And we know that area is equal to length times width. But we can't really use a formula that has two variables in it. But we know that the length is equal to 1 more than the width. So just thinking about that, I can replace the L here with W plus 1. And so my equation as a function of the width would be A of W is equal to W times quantity W plus 1. Of course, you could just do A of X equals X times quantity X plus 1 if you wanted to. And you could also simplify that if you wanted to X squared plus X. And so we're going to fill out a table, and most of this I think we can do by hand. We could certainly use our calculator if we want to, but if my width is 1, so that's 1, and then if I put 1 in for the width and add 1, that's 2, so I'm going to do 1 times 2, which is 2. And you should see a pattern here. If I do 2 for the width, then width plus 1 would be 3. 2 times 3 is 6, 3 times 4 is 12, 4 times 5 is 20, 5 times 6 is 30, and 6 times 7 is 42. And then number 8 says, between which two consecutive numbers should W be to make the area close to 24 feet? So we want the area close to 24 feet. Well, look here. If my width is 4, then my area is 20. If my width is 5, then my area is 30. So it's somewhere between 4 and 5, probably a little closer to 4, since 4.5 would be, we're thinking kind of close to 25. Anyway, so let's say about 4. Oh, it says between which two consecutive numbers? Between 4 and 5. It says find the value of W rounded to the nearest hundredth to make the area as close as possible to 24 feet. Now here's where we're going to use our graphing calculator, and it works pretty good. What we're going to do is put in this equation, which you can either write it this way, X times the quantity X plus 1, and just to show you that they're both exactly the same, or you could write X squared plus X, either way. And I'm going to go to my table. Now I know it's close to 4, right? And it said rounded to the nearest, I believe it said nearest hundredth. Find value rounded to the nearest hundredth. All right. So here's how you change your calculator to get hundredths on your table. Let's go to the table set to start with here. And we know it's between 4 and 5, so let's start at 4. And our table is right now going up by 1. That's where you see the cursor blinking right now. If we change that to 0.1, then we're going to be going up by 1/10. Now, some of you are probably thinking, well, why don't you go up by hundredths and then you can get the answer? And the reason is because we'd probably have to scroll through too much. This will be faster. So then I'm going to go second graph to get to my table. And remember, she wants it to be 24. So I'm scrolling down, and notice right here, the area is 23.76. And the next one goes a little higher, so it's pretty close to 4.4. But we need the nearest hundredth, so now that we know it's close to 4.4, we're going to go back to my table set and start it at 4.4, and then change this table interval to 1/100th. Now when I go to my table, I'm going up by hundredths. And this is the first value, that's 24 here. That one is 5 hundredths above 24. This one here is actually less than 5 hundredths below 24. So I think 4.42 is a little closer. Now, sometimes, just to make sure you're to the nearest hundredth, you could go by thousandths, and to do that, all you would do is go back to your table set. And we know it's close to 4.42. And we're just doing this to see if we can got it correct to the nearest 100th. If you have the thousandths showing, then you can round to the nearest 100th. And notice right here, 4.24 is actually a little bit below, 4.25 is a little bit above. Since that's above, we don't want to round that, so we're going to round it down to 4.42. And so our answer is 4.42. All right, let's do one more problem so you can kind of get the hang of that. Here we want our number 10, we want to use our calculators feature to approximate the solution of this equation. So we want it to equal 30 to the nearest 100. All right, so we're going to put in this equation in our calculator, y equals 2x times quantity x minus 4. And what we want is for y to equal 30 to solve it. So y equals 2x times quantity x minus 4. And then we want to figure out when that's equal to 30. So let's make our table start at 0 and just go up by ones to start. And then we'll check our numbers here. And we can see that it equals 30 somewhere between 6 and 7. And just knowing the characteristics of a quadratic, you probably know that there's probably two solutions. In other words, this thing goes up and goes down. So there's another solution between -3 and -2. So we have to find both of them. Let's find the negative one first, I believe. It says approximate the solution. Yep, there's two solutions. So let's get that one, the one between -2 and -3. I think it's closer to the -2, so when we go to our table set, let's put in -2, make it go up by tenths. And we're looking for 30, so we're going to have to move it this way. And wow, -2.3 is really close. So we're going to change this to, actually -2.4 is probably good. Change this to hundredths. Go back to our table and get as close to 30 as we can. And I'm thinking that right here is pretty close. So -2.36 is one of our solutions. So x equals -2.36. And x equals, now let's go find the other one. I think I remember that one being somewhere around 6, but we can get on our calculator quickly and figure that out fast enough just by going to table set, putting it at 0, making it go up by 1, and -30 was between 6 and 7. So we're going to go to table set, set it at 6, make it go up by tenths, and now we can see right here that 30 is somewhere around 6.4. So we'll start our table now at 6.4. Make it go up by hundredths. Go back to our table and get as close as we can to 30. And looks like 30.019 again, so 6.36. And that's how you use your table function to help you approximate solutions. Notice that in a lot of cases, the table can't get exact, but it can get pretty close. We'll learn some other methods later on for getting more exact. That's the end of the lesson. I'll see you tomorrow.